UJT characteristics and its applications as oscillator. The uni-junction transistor consists of a bar of lightly doped N-type silicon with a block of P-type material on it, one side, right? And this B1 and B2 are the base terminals. This is the picture of UJT, its symbol you can say. These are the applications of UJT. This UJT can be used as laxation oscillator. It can be used in trigger circuits, sawtooth generator, and pulse and voltage sensing circuits, and this can be used for over voltage detectors. This is the shape of the VI characteristics. This is a meter. On this side we are taking a meter voltage, and on this side is a meter current. If you see here now, this is the peak point where the UJT triggers, and this is the valley point where the negative resistance region. This is the negative resistance region. This portion you can say, this is the negative resistance region, right? Where at the valley point the negative resistance region ends. A meter current at the peak point represents the minimum current that is required to trigger the UJT. So that we already said, at valley point negative resistance region ends. So procedure for the VI characteristics: arrange the corrections as shown in the slide 6. Now set the voltage at VVB as 5 volts from a circuit diagram you can see. Increase supply voltage to meter, current on meter will increase, and note down the meter voltage and current readings. That will make a table also. At particular voltage, current will increase, and the voltage will be decreasing, right? You can see that also from the VI characteristics we can see. Now change the VVB. So earlier we have 5 volts, now we can change to 10 volts, and same VI characteristics we can study. This was the point A which we have already discussed. This from here we will set the voltage at 5 volt, and you can say you can change 10 volts also, right? At 5 we will set the voltage at 5 volt, then we will slowly increase the voltage from here. Voltage will increase, current will also increase, and particular voltage that is peak point you can say, peak current, particular current you can say, particular voltage you can say, the UJT triggers, right? So that we have already seen in the VI characteristics. Further, so that is, this is a circuit diagram which we already shown that we connected on the kit. That is a table which is showing us a meter voltage and meter current, right? We will try to increase the voltage. You can see here we are increasing the voltage slowly, right? And this current is also increasing. Slowly the current is also increasing, and you can see here also the voltage increasing, current is increasing. And at particular voltage, current particularly you can see now immediately increased to 60 mA, and voltage fast, right? So that this what we have done. This table has been made when the voltage given was 21.5. You can take any voltage, maybe 5, 10, 15, it up to you. Now this is the VA characteristics. You can say meter voltage and meter current characteristics. Basically, this is the peak point where the negative resistance region starts. This is the valley point where it ends also, right? So in this is actual graph taken from the actual readings. Now UJT can be used as laxation oscillator also. So make the correction as we are showing in the 10th and 11th slide. So get the CRO as the position of CRO basically we have changed only. One it is attached to ammeter and one as attached as base also. So when it is attached as BB1, then it is as a lesson oscillator, right? And we can measure the frequency. If you want to measure, we can measure the CR also. So that is the lesson oscillator basically, lesson oscillations. Here you can see also lesson oscillation there, right? Here the CRO is connected here base 1. Means output we will take from here, right? Nothing else. The output to CRO is one from B1 and other is from this network. This CRO we will try to get the B1 here, then to here this network terminal to other end in this way, right? And then we will change the CRO and we will put in the ammeter like this one. Now here one end of the CRO is connected to ammeter and second end is connected to the base, right? So that is another way. So in this way the shape of the this will be a shape on the CRO. If you see this, that is a connection. So this wire we will change. Once we will put in base 1 and then to the ammeter. In both the cases, so only this wire you should change. No other connection, no other change is required. Now this will be when the connected to base 1, so that will be the shape, actual shape on the CRO. And this precaution is there. Don't touch these two buttons because these are related to calibration. A small calibration indicator here, simply calibration here. Because if you touch it, so calibration will be changed and reading will not be real reading. Lot of error will be there. Similarly, this one, these are the oscillations. You can see that is the actual picture. So VE we are taking, right? That is the
V1, V2
video. In the previous case, VB1 is the lesson oscillation, right? VB1 is the lesson oscillation. So you see how to take the readings. This is the video
given to the ammeter terminal and note down the ammeter voltage and ammeter current variation with slightly increasing the ammeter voltage and ammeter current is nearly zero with increase in the ammeter voltage current is slightly increase and up reaching a maximum value known as a peak voltage. Voltage will be dropped and current will be suddenly increased. After a value, voltage will not increase and current will be slightly increased and voltage is almost constant. At this point is known as a value band. These are the VI characteristics of the UJT, and you can repeat this experiment for some other base V1, V2 voltage, say 10 volts.
And you can repeat this experiment for some other base V1, V2 voltage